Lesson 2. Forces, Equilibrium, and Friction. In this lesson, we look at forces, equilibrium, and friction. When multiple forces act at a point, their resultant is found by adding their vector components. If two forces act at right angles, you can find the magnitude of their resultant by taking the square root of the sum of their squared magnitudes. When an object is in equilibrium, the vector sum of all forces is 0, meaning the forces form a closed shape. For example, if three coplanar forces of 3, 4, and 5 newtons are in equilibrium, they form a right-angled force triangle, which means the 3 newton and 4 newton forces meet at 90 degrees. Similarly, if three equal forces act in mutual equilibrium, they form an equilateral triangle, so the angle between any pair of directions is 120 degrees. Next, let's consider friction. When an object is on the point of moving, it is in limiting equilibrium. Here, the frictional force equals the coefficient of friction, mu, multiplied by the normal reaction. If you are analyzing a rough surface, you might also encounter the angle of friction. The tangent of this angle is equal to the coefficient of friction. Finally, we use Hooke's law to find forces in elastic strings and springs. The tension or thrust equals the modulus of elasticity multiplied by the extension or compression, all divided by the natural length. Hooke's law applies exactly the same way whether a string is stretched or a spring is compressed, allowing you to calculate the magnitude of the resulting force.